My dear students, because of some technical problem, that video was discontinued. So I am continuing the same video. So this one we can write as sine square alpha plus cos square alpha plus 0. See, or cos square alpha plus sine square alpha plus 0. Okay. So see here, this cos alpha into cos alpha, sine square alpha, sine alpha into sine alpha plus 0 into 0. So this cos alpha sin alpha 0 you written as first row, and cos alpha sin alpha 0 you written as first row in second determinant. Similarly, what is cos alpha minus beta? Cos alpha plus cos beta plus sin beta plus cos alpha cos beta plus sin beta plus 0 into 0. This cos alpha sin alpha 0 should be written in the first row of the first determinant according to multiple principle, two determinants. Okay, first row to second row, first row of the first determinant and second row of the second row of the second determinant multiplication gives a second entry of the resulting matrix of first row. Okay, see here, cos alpha sin alpha 0 already we have written in the first row. So where we should write cos beta sin beta 0? In the second row of the second determinant. Similarly, cos alpha minus r. So same, cos alpha sin alpha 0 should be written in the first row, and cos gamma sin gamma 0 should be in the third row. So it was fitted. Once you multiply cos alpha cos square alpha sin square alpha plus 0, that is 1. So cos alpha cos beta plus sin beta plus 0, that is cos of alpha minus beta. Next, cos alpha cos gamma sin gamma 0 into 0 0, cos of alpha minus r, that is cos alpha minus r. Here actually it is gamma, but by mistake written r, so you can call as r or gamma, no problem. Similarly, you just write a same two rows of second determinant. Once you check it out, are you getting second row or not? Cos beta cos alpha, sin beta sin alpha. So cos beta cos alpha plus sin beta sin alpha means cos of beta minus alpha. Cos beta cos square beta, cos sin beta sin square beta plus 0. So that is cos square beta plus sin square beta 1. Next, cos beta cos gamma plus sin beta sin gamma, that is cos of beta minus gamma. We are getting same. Similarly, we get same third row also. So in any column or any row, all entries are zeros, then determinant is equal to 0. So this determinant 0, this determinant 0, total the product is equal to 0. Next concept, cofactor matrix. Cofactor matrix. The matrix obtained by replacing the elements of given matrix with their corresponding cofactors is called cofactor matrix of given matrix. Very, very important. The matrix obtained by replacing the elements of given matrix with their corresponding cofactors. You know what are cofactors? Cofactors means minors and cofactors, once you recall it. Okay, is called cofactor matrix of given matrix. That is, if A is equal to A11, A12, A13, A21, A22, A23, A31, A32, A33, then cofactor matrix of A. Generally, cofactors of A are denoted with capital A11, capital A12, capital A13. But here I have written in cofactor first letter C. So just I written C11, C12, C13, C21, C22, C23, C31, C32, C33, corresponding cofactors. You know how to write the cofactor of this one. It is cofactor of, if you want to write A11, so just leave the row and column passing through A11 and minus 1 whole power 1 plus 1 into minor of that one. Minor of that one means determinant of this 2 by 2 determinant. You know. Okay, like that, here you get plus minus plus. Directly you go for if you write minus the plus minus plus minus plus minus plus minus plus, if you write directly by taking these symbols, only minus you have to consider. You know how to do. Okay, most problems you completed. Now, adjoint matrix. Transpose of cofactor matrix is called adjoint matrix. For this one, this is the matrix, this is the cofactor matrix. If you take the transposition of this cofactor matrix, that is nothing but adjoint of this matrix. Transposition of this matrix is nothing but adjoint of this matrix. Once you go through one example, find adjoint matrix of 1 2 1 3 2 minus 3 1 1 2. Okay, cofactor matrix I am writing here. So this is wrong. See here, cofactor matrix, how it is a 3 2 3 only, not minus 3. Okay, see here, first here you get a plus, directly I am writing it plus into minor, 2 2s are 4 minus 3, that is 1. Next here you get minus minus symbol, minus into, leave the round column passing through 2. 3 2s are 6. 6 minus 3, that is 3. So minus 3 we get. It is plus 1, leave the round column passing through 1. 3 1s are 3 minus 2, that is equal to 1. Next, for this one you get minus symbol. So minus with minor of this 3. So leave the round column passing through 3. You get minus of 2 2s are 4 minus 1, that is minus 3. Next, for this 2, leave the round column passing through 2, here get plus symbol. So 1 into 2, 2 minus 1, that is 1. It is minus, minus you get. So leave the round column passing through this 3. So 1 into 1, 1 minus 2. Okay. So 1 minus 2 means minus 1. Minus into, for this 3 you get minus. Minus into minus plus 1. Similarly, for these 3 cofactors are nothing but 4 0 minus 4. Okay, this transposition is nothing but adjoint of A. This is okay, this transposition is nothing but adjoint of A. Adjoint of A is nothing but transposition of this one. So write as rows as columns. 1 minus 3 1, minus 3 1 1, 4 0 minus 4. So this is the adjoint of A. If you go for shortcut method directly, so how to write the shortcut is second row, you start with second row and a second entry 2 3 continuation order 2 3 3 2, 2 3 3 2, and go for a third row 1 2 1 1. Start with this here. Okay, start from second entries in all rows. So 1 2 1 1 you have to write. So 1 2 1 1. Next go to first row. So first row is here. So 2 1 1 2, 2 1 1 2. Next again second row, at second row we should stop. So 2 3 3 2, 2 3 3 2. You should write like that. This is a cross multiplication method like that. Coefficients, how you write coefficients of x, y and constants like that. But here you should start from second row. Okay, second row, third row, first row, again start with end with the second row. See here we have to do one thing. So this cross multiplication, 2 2s are 4 minus 3 1, 3 1s are 3 minus 6 minus 3, 3 1s are 3 minus 2 1. So this cross multiplication gives first row. Next, this cross multiplication gives second row. This cross multiplication gives third row. This transposition is nothing but adjoint of the given matrix. See here, you get 1 minus 3 1 minus 3 1 1 4 0 minus 4. Transposition, what you have? 1 minus 3 4, columns as rows, minus 3 1 0, minus 3 1 0, 1 1 minus 4. Okay, so like that you have to do the transposition. Okay, that is nothing but adjoint of the given matrix. Next, I am discussing just properties of adjoint, very important. Adjoint of identity matrix is nothing but identity matrix. Same matrix you get any order. Adjoint of null matrix gives a null matrix only. Adjoint of Ka, that means if you multiply any constant to a matrix, if you want to find out the adjoint of that matrix K into A, that is nothing but K power n minus 1 into adjoint of A. Here n is nothing but order of this matrix. Okay, we just follow this concept here. If A is a symmetric triangular diagonal matrix, then adjoint of A is also symmetric triangular diagonal. Okay, if A is singular matrix means determinant of A is equal to 0, then determinant of adjoint of A also 0. Determinant of adjoint of A also 0. Okay, next one, we take one example. Here one more point, very important. A into adjoint of A is equal to adjoint of A into A is equal to det A into I. It's very important. A into adjoint of A is equal to adjoint of A into A is equal to det A into I. If you remember this one, sometimes they may ask find the, they may give one matrix and find the A into adjoint of that matrix. Then no need to find out this adjoint of A. Directly this value becomes to det A into I. Proof of this one is nothing but that A is equal to A1 B1 C1 A2 B2 C2 A3 B3 C3. Now adjoint of A is nothing but what? So adjoint of A, in a adjoint of A, cofactors of this one you take as capital letters. Okay, this cofactors with the transposition gives adjoint of A. So directly adjoint of A is nothing but so just you write A1 B1 C1 cofactors. If you take capital A1 B1 C1, then A1 B1 C1, A2 B2 C2, A3 B3 C3 whole transpose. This is nothing but A1 A2 A3 as first row, B1 B2 B3 second row, C1 C2 C3 third row. Okay, now you multiply A into adjoint of A. A into adjoint of A is nothing but what you understand, this is nothing but small letters. So this is A. Okay, this is A. Adjoint of A is nothing but this one. Just I do one thing here without disturbing that paper. So what is that? A means what here? A1, B1, C1, A2, B2, C2, A3, B3, C3 into capital A1, capital B1, capital C1, capital A2, capital B2, capital C2, capital A3, capital B3, capital C3. Okay. Now A1 into capital A1, B1 into capital B1, capital C1 and C1 into capital C1. What is this? Here A1, B1, C1 are the first row. Okay, entries. A1, B1, C1 are the corresponding cofactors of this same row. The sum of the product of the elements of any row 2, okay, its corresponding cofactors only is equal to det A formula. Same way, sum of the product of the elements of any row 2 corresponding cofactors of any other row or column, any one. Okay, if it is column, column wise, row wise. Okay, sum of the product of the elements of any row 2 corresponding cofactors of any other row is equal to 0. So that means A1, B1, C1, A1, A2, B1, B2, C1, C2. These A2, B2, C are the corresponding cofactors of other row, second row. So this product becomes to 0. Did you remember? Same way, A1, B1, C1, if you multiply with A3, B3, C3, that is also 0. Same way, if you multiply like that, first row to this first column gives that A. First row to second column gives 0. First row to third column gives 0, 0, 0. Okay, 0, 0. Next, second row to first column A2, A1, B2, B1, C2, C1. This is second row elements. These are the first row corresponding cofactors. So product gives 0. So 0. So and again, same way, second row, second column A2, A2 plus B2, B2 plus C2, C2. This gives det A. So det A. And this gives 0. Similarly, third row you get 0, 0, det A. Okay. So from all these entries, if you take det A common, what you have 1, 0, 0, 0, 1, 0, 0, 0, 1. This is nothing but det A into I. So that is only the proof of this one. So det A you can write this one or det A symbol. Anyone you can write. Okay. You take one example. If A is equal to x32, 1y4, 2z and xyz is equal to 13, 8x plus 4y plus 3z is equal to 12, then A into adjoint of A. What is the formula A into adjoint of A? That is nothing but det A into I. Directly you go for determinant of A. Okay, determinant of A is nothing but x into yz minus 2 4s are 8, minus 3 into, actually plus minus plus. Okay, minus 3 into, leave the row and column, 1 into z minus 2 4s are 8, plus 2 into 1 into 2 minus 2y, 2 minus 2y into I. So this is equal to xyz minus 8x minus 3z plus 24 plus 2 plus 4 minus 4y into I. Okay, I means identity matrix. So this is equal to xyz minus 8x minus 4y minus 3z plus 28 into I. So this is equal to actually they given xyz is equal to 13, 8x plus 4y plus 3z is equal to 12. If you take minus common, so you write as total for this one minus 212 plus 28 into I. This is nothing but 29 into I. Okay, 29 into I means 29 is the constant, I is the identity matrix of 3 by 3. So if you multiply 29 inside, 29 0 0 0 29 0 0 0 29. This is the answer for that question. So remaining properties we will discuss next video.